So like we said before, margin and error sampling methods, not on this preview itself, but it will be there on the actual quest test quiz that you're taking tomorrow. So get that out of the way. All right, so we've got a sample, always important to know whether it's a sample or not, of 12 snowboard prices shown below. What's the standard deviation to the nearest hundredth? Now, we've talked before about how we can calculate this, but we'll get several opportunities to kind of play with this again. We're always going to start in the stat menu, so just here to the left of your arrow buttons. We want to edit first because most of you will have a list here. If you do, again, just keep it simple, arrow all the way to the top, highlight your list number, hit clear, and then come back down. It'll wipe it out for you. And hopefully nobody's done anything too silly to it. So once we've got that cleared out, we're just going to start putting in these values so we can get any information that we may want out of this. And I never did show you how you would have to manually do all this stuff with standard deviation if you'd have had to go that route. It's bad. Subtracting the mean from each score and then squaring that and adding them and taking the square root of it, yeah, it's not fun. Let's see here. 370 and 392. And it says 12, and I have 12, so I'm happy about this. Now again, when I go to do the standard deviation though, I'm going to be back in the stat menu, except I'm going to right arrow one to where we're calculating. We want the variable statistics, number 1. And then I just tell the calculator what list I want by hitting second and whatever number my list was in, L1, L2, whatever it happens to be. But here's again where I have to be careful, because this is a sample. So I have to use the sample for standard deviation. Holy moly. All right, thank you. So what we're going to do is we want the one that looks like the S in front. S and sample, they go together. And we go to the nearest hundredth. It would be A, or 22.49. I have to be careful because if I take the one for an entire population, that answer's there. So I can't get sloppy on this. So whole population, just the sample. So if we... interquartile range. Okay, same idea going though. So again, I've got to get all of my data in here. So we'll clear all that stuff out. And we've got to go back to our list. Now, if you don't want to erase your other list, you could just side arrow and start typing if you wanted to, but I like clearing my list. Oops, let me get back to the top here. There we go. So I'm going to type in my number of cans each week here. So there's lots of applications that we can get out of our statistics menu. Okay, we've got 12 values again, so we're good there. Now, interquartile range. There's not a specific, because again, interquartile ranges are down here a little bit further on our variable statistics, but it's not immediately right there. If I wanted to make a box and whisker plot, I could with this. But the interquartile range is always going to be your third quartile minus your first. It's that middle area. It's that area that we find in the box in a box plot. So I have to do a little math this time. So my third quartile is 60. My first quartile is 29.5, and I'm just going to subtract those. So basically every other bit we'd have on there, the max, the min, we could figure out the range, the interquartile, the median, all that stuff. But that's one where I got to do a little bit of thinking. All right. So as we flip over, we've got a movie theater recorded the number of tickets sold daily for a popular movie during the month of June. Box and whisker plot shown below represents the data for the number of tickets sold in hundreds. So keep that in mind. Or if you want to, we can just stick zeros on these so we don't get confused possibly. So what do we need out of our data here? Okay, what conclusion can be made using this plot? Okay, the second quartile is 600. Well, not exactly. Because again, remember, when we're looking at a box and whisker, our max and min are out at the end. Mine normally look like dots, but little dashes don't hurt anything. The start of my box is my first quartile. The end of my box is my third. And my median is in the middle, and I can call that my second quartile if I wanted to. So I look, second quartile 600. Nope, that's the third one. Okay. The mean of the attendance is 400. Ooh, be careful. It's an M word, it's at 400, but it's not the right M word, because this is our median, not our mean. So that causes a problem. So it's not B. The range of the attendance is from 300 to 600. Again, tempting, but not correct. Because again, my range goes from the min to the max. This would be talking about interquartile range, the 300 to 600, between those two. So answers are close, but still not right. You're like, well, this better be right. 25% of the attendance is between 300 and 400. We talked before about in a box and whisker plot, each part represents, bless you, exactly 25%. So 25% of my data is between 300 and 400. So 3 is going to be D. But I have to read in really carefully on that, or I can get myself into all sorts of issues. So, let's see here. 25 students were surveyed about the number of days they played outside in a month. The results of the survey are shown below. On the grid, create a histogram based on the data. Okay, now this might be one of the stranger histograms you've seen, because these go by threes, and sometimes, well, these are numbers in between too. So I'm going to have to kind of make my bars a little bit skinny. But like here, for instance, I've got 1, 2, 3s. So get my skinny bar going here. At my 3. 1, 2, 3. I got 4 4s. So get those marked off. I only got 1 5. Mark that off. Holy cow, we got a lot of these. 1, 2, 3, 4, 5, 6, 7 6s. One, 2, 3, 4, 5, 6, 7s. One 16. 1 17. 2 22s. And 25. That's kind of all over the place. Definitely looks like we would be skewed positively if we were being asked that, but we're not. But here comes the interesting part. Identify the typical number of days spent outside by the 25 students. Fancy way of asking you for the median. Now, could I type those all into the calculator and get an answer? Sure, I absolutely could. You're like, but you're not going to, are you? No. To me, it's going to take more time to type those 25 numbers in, because I noticed the list is in order already, so I don't have to worry about that. So if I start working my way in from the edges, I'm going to find that middle number pretty quick. And I also had a pretty good idea before it was going to be 6 or 7. It was just a matter of which one is it going to be. And I get to the middle, and it's 6. Would I get the exact same answer if I put it in the calculator? Absolutely. So, just something that you may want to know, or something like that. I could have done it by the list, I could have done it by the calculator, and I may even have been able to do it using my histogram if I really wanted to. But it's understanding what the words are and what they mean. It's going to kind of help out there a little bit. Oops. Use the statistical features of your calculator to find the standard deviation of the set. Okay, back over. You're like, see, I had to punch it all in the calculator anyway. Well, sometimes. All right. We were hoping we were going to get out and not having to type all of these, but that's okay. So 3, 3. 4 4s, a 5, 4 6 7 6s. 1, 2, 3, 4, 5, 6, 7 of those. 2, 4, 6 7s. 2, 3, 4, 5, 6 7s. A 16, a 17. 2 22s, and a 25. And I have my 25 bits O data, because again, I know with 25 students. So let's see here. What are we looking for again? We're looking for the standard deviation. Now, here's where we may need to think a little bit. Come back here one more time. 25 students were surveyed. Question: do we think that this is a population or a sample? Sample, because it doesn't mention like all the students in a class, all the students in this room, whatever. I would assume that's going to be a sample. So if we go sample, again, we're going to go with this guy. So 6.38 would be our standard deviation in the nearest hundredth. So again, unless you have something that believes you are going to have all of something, you want to definitely go with the sample on those. All right, Mrs. Garbinski teaches 3 algebra classes, periods 5, 6, and 7. Yesterday they took an exam. Here are the box plots that represent each of her classes' test results. Answer the following questions. And of course, I'm not going to be able to get all 3 of them down here on the screen, but hey, this is how it works. So what's the class median for each class? So what are they? What about for 5th hour? 76, because again, my median is going to be that middle bar in my box. So for the last 2 as well, wherever that bar is, so for 6th hour it's at 90, and then it's at 84 for 7th. Those would be my medians for each of the classes. So then we've got, what is the upper quartile for the 7th period? Now, upper quartile is another way that we can represent our 3rd quartile. If you were ever to see the term lower quartile, that represents Q1. So what is our Q3 for 7th period? About 92. So 92, okay. Which class had the greatest range of scores? The biggest gap between my min and my max? Definitely 5th. So again, you just do max minus min. Okay, for the 5th period class, which quartile did most of the students score? Now again, we know that we have labels for quartile 1, quartile 3, median could be called quartile 2. But when we're looking to say, okay, this area right here represents my first quartile. We only just label the top value. So quartile 1's here to here. Quartile 2 runs from Q1 to Q2. My third quartile runs from 2 to 3. And then my Q4 would run all the way for the rest of it. So which one of those includes the most? Quartile 4. Because I look at 1, I've got 12. And then here I got 14. That guy's too short. And this guy's got 16. So in this case, my 4th quartile is going to have the most data, or the most student scores. What was our lowest score for 6th hour? 52. Because there's my min. So I can grab that out of there. What was the 75th percentile for the 6th period class? What's my Q3? 97. Because we talked before about, and again, it's just language issues, how each piece of a box and whisker plot takes up 25%. So if we put that along with what we talked about up here, okay, here's my 25th percentile, my 50th percentile, my 75th percentile, and then way at the end it'd be the 100th percentile. So to be in the 75th percentile, and you'll see this when you get test scores back in the mail and stuff, it'll be like, you scored in the 91st percentile. What that means is that you scored higher in this case at least, you scored higher than 75% of the students. All of that data that's behind you are people that scored less than you did. So if you're in the 75th percentile, you did better than 3/4 of your classmates. That's not a terrible deal. So then one last thing here, because again we played a little with standard deviation and mean and median. So now we want to play a bit back with the empirical rule. Now, this is going to take us back. There it is. To when we were using this before. And again, you're getting something similar to this when you take the quest tomorrow. So don't panic if that's not completely into your brain yet. So okay, in a normal distribution, what percentage of my values lie below the mean? 50%. And another 50% are above the mean. Okay, so what percentage of my values lie within one standard deviation, that's to the left or right, of the mean? 68. Because if I cover one each direction, it has to take all those values in between. 68% of them. What about within two standard deviations? 95. Because again, we're just expanding both negative and positive to the left and to the right. And you can even cheat a little bit and look down at the bottom. And then within 3, almost all of them. The only part we won't have at this point is that 0.15 that's on each side. So we got 3/10 there, but 99.7% of them will. So now we can actually apply that a little bit. We got 2,000 freshmen at State University took a biology test. Scores are distributed normally with a mean of 70, that's in the middle, and a standard deviation of 5, which just means the scores go up 5 for each deviation to the right, and down 5 for each deviation to the left. Now, you can either maybe just look at this according to, you're like, okay. Maybe look at it this way. Or maybe some of you even want to recreate what we had before and maybe kind of separate this a bit so you can literally have the percentages right there in front of you. It just depends on your comfort level. So once you get that sketched in, or maybe you're just pulling this out, who knows, then I can start to take a peek and start to actually get some data from this. So for instance, let's see here, what do we got? What percentage of scores are between 65 and 75? Hence seeing why it's nice to put the percentages in, because it makes it a little bit easier to just jot answers down then. What percent are between 60 and 70? And again, as long as I can add, it doesn't become too complex of a deal. I'll keep quiet for one here. What percentage of scores are between 60 and 85? I heard. Because again, we catch everything except the 2.5% over here and that extra 0.15 over here. If you're kind of looking, if you're kind of looking and going, where's this 0.35 thing coming from? That 2.5 and 0.15 would be 2.65% that we don't cover. How many are less than 55? Yeah, not very many. It's the dropout group. What percent of scores are better than 80? 2.5. And then we can actually start coming up with some values, some numbers. How many biology students scored between 60 and 70? Well, we know it's 47.5%, but there were 2,000 people that tested. So I'd have 2,000 times 47.5% as a decimal. Don't forget the decimal part of your answer is not going to make any sense. So nearly half of them got between 60 and 70. Eee. And then how many scored between 55 and 60? Again, not very many. Don't forget that 0 in there. I believe you're going to get about 47 if I did my mathematics correctly here. But again, that's some actual applications for us using our empirical rule. Okay, with our standard deviations. So you're like, okay, seen quite a bit of this. This is not looking too bad. This is not looking too awful. So one more little piece here with some of that stuff. And again, it's just using the information and actually applying it to something. So for instance here, calculate the mean and standard deviation. Now here, since it didn't say it was a part of a group, on this I'm going to be using population because it didn't say it's just out of this many or this part, sort of like number 2 does. 6 shops. Well, how many shops are there? There are 50 shops, shops nationwide, I don't know. That I would do a sample for. But otherwise, I'd probably just keep using populations for these other pieces. And this may be one of those situations that I use both of these lists at once. So instead of typing this all in and then going away and coming back, maybe you decide you're going to pop both lists in here while you're already at this screen anyway. Now, does it mean I can look at all the info at once? No. Once I get it in, I still can only do them one at a time, so I'll do list 1 here first. And I need the mean, which is the x with the line over it. And again, if we're doing our population on these, my standard deviation would be 3. But now instead of having to go back in and do all that stuff again, I got all my data typed in already for the second one. So I could just go back to stat. And this time, I'm just going to hit second and 2, and I want my list 2 info. And I can get it just like that. And again, since we said we were going to go population this time, sneak that over a little bit and get my value that way. But for the rest of these that are on here, since there's no specific value of whole class, the shop's in a town, something, these I would definitely be looking at more as samples. And I'm only going to do number 2, and then I'm going to skip a little bit because there's more application on what you're actually typing in down below. I know you're capable of typing in numbers and getting values. So I'm not going to go crazy with those. Okay. So one more here. So we got 47, 49, 50, 44, 48, 44. And again, to get them, I just want to get into my variable stats and tell them what list I want. So my mean is 47, and this time we're going sample. So my standard deviation would be like 2.53. Then I start to ask some other questions. So we're going to take a peek at 4 and 5 because they have a little more of an application base to them. And then we'll call it good and we'll see how we're feeling with stuff. So the marks of 7 pupils in an advanced higher maths exam. Can you tell this is like English? We don't speak this way here. So let me get that cleared out. So we'll get our scores put in here. All right. Okay, calculate the mean and standard deviation. All right. My mean is 73. My standard deviation, 16.8. Ouch. Now here's where we can actually apply something though. Another group of 7 pupils who sat on the same exam had a mean of 78 and a standard deviation of 3.2. Make 2 comparisons of the marks of the 2 groups. Well, the obvious one, of course, be the second group averaged higher. Okay, that's the simpler one. What can the standard deviation tell me? Right. That second group, their scores were a lot closer together. Their scores were more consistent, maybe even, let's say. We may have had a couple of real oddballs here. Maybe somebody got 100 and somebody got like a 20 or something like that. So the second group is also more consistent. Or maybe you bust out the word outlier with the first group, because a standard deviation of almost 17 on a 100-point exam is yowzers. Pretty large. And then one last one here. Probably won't even need the sheet to do this stuff after we've done so much stat work here. All right. So one last group. We're looking for temperatures in a greenhouse. All right, so we got 7 temperatures we're working with here. Mean and standard deviation. All right, so the mean is 19. Standard deviation. Now, what do you think this time? Sample or population? I agree, because it's one gardener and he recorded them every day, so we have all the statistics here. So I would say the standard deviation this time is a population. And I'd say it looks like it's about 3.46 degrees. So now, for best growth, the mean temperature should be 20 plus or minus 5 degrees Celsius, so between 15 and 25, and the standard deviation should be less than 5 degrees Celsius. Are the conditions in the greenhouse likely to result in best growth? Yep, we're within the 5, we're within the plus minus 5 there. So we can actually apply something. Now again, the only thing besides what you've seen on here will be that margin of error. And again, margin of error, if I tell you there's 400 people that got surveyed, what's that percentage? You just are going to do 1 divided by the square root of 400. It'll tell you the percentage or the margin of error there's going to be. And then just again, getting a feeling, maybe go back and read back on pages 9 and 10 in the packet, I believe is where they're at, with what the different sampling methods are and some examples, because there'll be a couple of multiple choice questions on those. Otherwise, you've got everything with this.